Hey guys, welcome back to my channel. In this video we are going to start with the principle and theory. In the previous video we have discussed the important questions, right? In this video we will complete the uh, principle and the theory involved in mass spectroscopy. Very carefully you should listen it, because every concept is linked, and if you understand the principle and the theory and the instrumentation, everything is very easy. Okay, let's start this. Mass spectroscopy is the one of the uh, one of the most primary spectroscopic method for molecular analysis available to the organic chemist. Here, mass spectroscopy is the one of the most important or primary method for analysis of the molecular analysis. Okay. It is an microanalytical technique requiring only a few nanomolecules of a sample to obtain characteristics information pertaining to structure and molecular weight of the analyte. Here, it requires only nanomolecules, means very small quantity to analyze the sample. Okay, so it is called as microanalytical technique. Mass spectroscopy is a destructive technique because it breaks molecules apart during analysis. Here, it's also called as destructive technique because here the sample is break down into many pieces. Okay, or fragmentation process takes place, right? Breakdown of the parent molecule into smaller molecules so that the sample is destroyed. It is called as destructive technique. Okay, we will go with the principle. Mass spectroscopy is the most accurate method for determining the molecular mass of the compound and its elemental composition. Okay, uh, here for determining the molecular mass of the compound and its elemental composition, mass spectroscopy is most accurate method. Okay, by this technique we can determine the composition as well as elemental composition and molecular mass. In this technique, molecules are bombarded with a beam of energetic electrons. Here, the energy and energetic electrons will interact with the sample. They what they'll say, collision takes place between both of them, the sample molecules and the electrodes. Okay, by this the fragmentation occurs. By the fragmented ions are used to analyze the sample. The molecules are ionized and broken up into many fragments, some of which are positive ones. Only we need the positive ones to analyze the sample. Okay, see, the molecule are broken down, are ionized. First they are ionized and then broken down into many fragments. Okay, there are different type of ionization techniques. By this molecules are ionized. Okay. Each kind of ion has a particular ratio of mass to charge. It's also called as mass to charge ratio values. For most ions, the charge is 1 plus, and thus m mass to charge ratio is simply the molecular mass of the ion. Here it is. Here we are telling that due to loss of electrode, right, we will there is a loss of electrodes and the positive charge will be uh, getting on the molecular ion. Example, Na plus. Okay, by removing the electrons from the sodium, we will get Na plus. Only positive charge are used to analyze the sample. Okay, here if see m by e, right, if e is 1, then it is directly proportional to m, right? If below is 1, m will be the numerator, which is mass of the sample, and denominator is charge. If charge is 1, then it is directly proportional. You can write it m, right? You can just write m. Okay, that's what it is telling. The mass to charge ratio is simply the molecular mass of the ion. Mass to charge ratio, we are just telling mass to charge ratio, but it is simply molecular mass because charge is 1, right? Mass divided by 1 is m itself. That's the principle involved in this mass spectroscopy. I think so I have understood. See, next, mass spectrum is used in two general ways. After the detection, there is production of mass spectrum. There we use it to identify identification of two compounds or to establish the structure of the new compound. First we will identify the compound, or we will establish the structure of the compound. Okay, mass spectrum of the compound helps to establish the structure of a new compound in several different ways. Okay, using the mass spectroscopy, how it establishes the structure of a new compound. It gives the exact molecular mass, it gives the molecular formula. Okay, by these two ways the new structure is established. And we will go with the theory. If you understand, you will understand everything here. uh, a parent ion resulting from one electron is removed from the parent molecule of the substance. If one electrode, this is takes place in the gaseous state, if one electrode is removed from the parent molecule, it will get an positive. This is what we need. Okay, this is what we need for analyzing of the sample. Okay, because uh, here they are interactive. Okay, now the sample is interactive. Okay, it can absorb the energy. Okay, or it can absorb the electrodes. By we need this state for the mass spectroscopy. The mass to charge ratio values of the parent ion is equals to the molecular mass of the compound. Here uh, it is telling that the mass to charge ratio of parent ion is equals to the molecular mass of the compound. See, as already I said you, right? If mass to charge ratio m divided by e, if e is 1 and mass is the total mass of the compound, then it is, if e is 1, then directly is proportional to m, right? That's what it's telling. The mass to charge ratio of parent molecule is equals to the molecular mass of the compound. If charge is 1, it is directly proportional to the molecular mass of the compound. Okay, I think so I understood it. Mass spectroscopy is designed to perform three basic functions. What are the basic functions to perform, or the process? Okay, first, to vaporize compound of varying volatility, to produce ions from the neutral compound in the vaporous state, to separate ions according to their mass over charge ratio and record them. This is the basic three functions. How it is involved? First, the molecule is present. Through ionization, we remove the electrodes and convert into favorable positive charge. These are called molecular ions. Then, through fragmentation, we break the molecule into many parts. Then, M1 and or M2 radical, there are cations and radicals are formed. These are used to analyze the compound, and these are arranged according to their mass to charge ratio, and we record them. And recording is it produces a spectra, and the spectra is used to identify the compound. This is the basic principle and theory involved in NMR spectroscopy. In the next video we will start with the instrumentation, and we will continue and everything. By end of the day we will complete the mass spectroscopy. Thank you guys for watching this video till now, and be support my channel, like, comment and subscribe. It will directly motivate me so much. Thank you guys, study well, see you in the next video.